Hi, thank you for coming to J4K. My name is Deandrea, and I'm here to talk to you about how about some tests with your applications. I am a developer advocate at Red Hat. I've been doing software development for 20 some odd years. I spent most of my career before joining Red Hat as a architect and software engineer in financial services and insurance. I've long been a contributor to many different open source projects. Currently, I'm a part-time contributor with Quarkus. I've contributed to various of the Spring projects in the past. I build and deliver lots of different cloud native development training programs. I write articles, I write blogs, I've written a book, which we'll talk about in a second. And as you can see from my picture, I love to be out in the water. I live in New Hampshire, so lots of great mountains and lakes to hang out in. That's where you'll catch me when the weather's nice and I'm not at work. And I do hold a black belt in martial arts, and you can see all my different social handles there. I'm pretty easy to get a hold of. As I mentioned, I've written a book towards the end of last year, beginning of this year, looking at Quarkus through the lens of a Spring developer. Any developer who's familiar with Spring or any of Spring's conventions and concepts and how they map to Quarkus, looking at like for like code examples between Quarkus and Spring with a big emphasis on testing patterns and practices, which kind of leads into today's talk about how to write good tests and the tools available for writing good tests. It's a free download. I don't make any money from it, so if it's something that you want to take a look at, please feel free, download it, and give it a read. And hopefully, it'll be a good learning tool for you. And so, why are we here today? So, we all know that moment when we've spent hours or days or weeks working on something and we click the button and it finally works. It's like, hooray, yeah, it all works. But how do you get there and how do you know that it works? Can you really, just because it works at your machine, can it really go into production? Right? We've all been there where, hey, it worked on my machine, or the build passed. Let's just push it to production and see what happens. In reality, we'd love to do it, but we really can't, especially if in this microservices world where your application might be part of a larger distributed system. Because if you do, this might end up happening as you start to deploy things. You might introduce bugs, and then as you start fixing the bugs, you introduce more bugs. Right? And we don't. That's certainly not something we want to have happen, because it's just kind of soul sucking from you, right? You want to be working on the new cool stuff, not fixing broken stuff. Or maybe you work in an organization where this is how you explain it. If the user only did it this way, then everything would just be fine. But what we really need is for developers to be able to write tests for the code that they write, and to be able to run those tests automatically before code makes it into version control, because it's always faster and cheaper to find and fix the bugs before they make it into version control. The whole shift left initiative, the sooner you find them and fix them, the cheaper and faster it is to fix them. And hopefully, you can get away from the bugs completely and go work on good new stuff. But as you start to write more and more of these tests, you might find that this sometimes starts to happen. You get the daily email from your ops team say, hey, the build's broken. You need to go fix this test because it's doing something and it's causing the build to break. Right? So rather than figure out what's going on, you just start disabling tests. Yay. And so now your build passes, or you just stop writing the tests completely. And that brings you right back to the beginning of this vicious cycle, right? Tests are a good thing and they should be run all the time. And if they break, we shouldn't just turn them off or stop writing them completely. But the point is, the writing a test does not have to be hard. There's lots of tools out there that can help make it easier, or maybe even fun to write. Do I dare say fun? Nobody's ever said writing tests and fun in the same sentence before, right? So this is probably now what you're all thinking. So I'm going to go ahead and prove it to you. So today's challenge. So we're going to build this pet adoption application where we have a Quarkus application that over REST gets and stores pet information, uses Hibernate to persist it into a Postgres database, and then can perform adoptions over events that come in over Apache Kafka topics and sending events back. Now, this talk is supposed to be a 60-minute talk that I had to shrink down to 30 minutes specifically for J4K. So either I've got to talk twice as fast, or we've got to kind of cut some of the stuff out. And so unfortunately, the Kafka part of this, we're most likely not going to get to as part of today's session. But I do have, and I can do this talk again in a full 60-minute time slot, and we really can build an entire application from a test-driven development approach with a complete set of tests in an hour. And yes, those really are my pets up at the top, and no, they're not up for adoption. I just had some white space that I wanted to fill with something cute here. Sound good? So let's get started. And if you're interested, the QR code that's there, you can scan it, and it will bring you to a repo which has all of the application already built out for you. So let's go ahead. All right, so we're gonna use IntelliJ just because that's my tool of choice here. Come in and we're going to add a bunch of extensions, which are like libraries that we're going to use with Quarkus. So we need Jackson for JSON marshaling. I need some Hibernate stuff. I'm going to do Hibernate Validator, Hibernate with Panache. Panache is just a abstraction layer on top of Hibernate to make it easy to use with Quarkus. I'm going to add a Postgres driver, the JDBC driver, and I'm going to add the Jib container extension, just in case we get as far to be able to generate container images. And now that we've got our IDE up, you can see it's a pretty empty project here. There's not a whole lot of stuff here. There's some example code that's in here. A resource is an empty properties file. There's nothing in there. There's a couple of tests that are generated from here. We're not going to really bother with those. We're going to kind of leave them there. And then we're going to come in here to the POM, and one thing we need to change is we're going to use Java 17. The IntelliJ tool, for some reason, even though I'm using 17, always likes to put 11. And then we're going to add a couple extra test dependencies in here. We're going to add the Mockito extension. So if you've used mocking and spying and stuff before, Mockito is a great tool. It plays real nice with Quarkus, and the AssertJ library for Java-based assertions. It's pretty widely used Java library as well. So we're going to come here. We're going to fire up what's called Quarkus Dev Mode, which allows us to do our live coding. And the first thing you'll see is it says this Hibernate ORM is disabled because there's no JPA entities. Well, that kind of makes sense because it's a brand new project. We haven't written any code yet. But it also says this dev services for the default data source Postgres has started. And that it set this Hibernate database generation to drop and create to initialize the dev services managed database. So what does that mean? So I'm going to hit the D key here in this terminal, and that's going to bring me to a browser. And if you notice, if I click on this dev services here, it actually started a Postgres container for me. It noticed that, hey, you've got a Postgres driver on your class path. So rather than, because you didn't provide any configuration, Quarkus actually went ahead and downloaded and started a Postgres 14 container for me and bound it to my application. So you can see all of this configuration that Quarkus injected automatically, and you can see the drop and create that it did for me. So that's pretty cool. So I didn't even have to do anything, and Quarkus just kind of worked out of the box without me having to do anything. So the next thing I'm going to do is I'm going to turn on Quarkus's continuous testing feature. So I'm going to hit R to resume tests, and you notice it's going to start up another Postgres database and to run the tests again. So it keeps the application and the test data sources and databases separate from what I'm doing here. So that's pretty cool. So I'm going to close this stuff down, and so let's start creating things by writing our tests first. So the first thing we're going to do is we know we need a database, and we know we need some kind of abstraction on top of our database. So we're going to call that a pet repository. So I'm going to create a pet repository tests class here. I'm going to annotate it with Quarkus test, and I'm also going to annotate it with this test transaction. And what that says is that every test Quarkus is going to run in an isolated transaction. So if I modify the state of the database during the test, Quarkus will revert it back to its previous state when the test is over. So I'm going to inject a pet repository, which doesn't yet exist, which is why it's in red, and IntelliJ is not happy. And then I'm going to throw in some test methods here. So the typical way you write tests is you start by setting up whatever your state's going to be, then you apply some stimulus, and then you do some kind of assertions. And so the first thing we want to do is we want to create this up, and now you can see the continuous testing went in and says, hey, it doesn't know what this is. It tried to run the test, but it can't. So let's go ahead and create this class. And I'll move it side by side just so we can keep them both side by side. So we're going to turn this into a bean by making an application scoped. And then Panache also has a lot of this cool base interfaces that we can use. So we're going to create a Panache repository around a pet. And then we're going to add in a couple of methods here that one for finding pets by giving a kind of a pet, and one that adopts a pet if the pet is found. So next thing we know is we need to create this pet class, right? So we need a couple of annotations here, which are standard JPA annotations. We need a couple fields here, so we'll keep it pretty simple. We've got an ID, a name, a kind, and a field for adopted by. Couple of constructors. Now you could say, oh, what about Lombok would save you from having to do all this kind of stuff. Well, you could use Lombok. Lombok and I don't really get along very well, so I prefer not to use it. But if that's your game, then by all means go for it. I'm going to generate some getters and setters, and then I always like to generate two string methods, and I'll let my IDE do it for me. And now my pet class is done. And now let's import. So our implementation doesn't do anything yet, but now we can go ahead and write the tests, and oh, all the tests pass. Well, it's because we haven't really implemented anything yet. So let's go ahead, and our first test will be, we're going to delete everything, make sure we start with empty state, and then we're going to assert that, if I could type right. Pet repository.count. It's not finding my thing because it didn't import for some reason. There we go. We got assertions. Assert that there's nothing there. And now I can persist something. A new pet. I'm going to call my cat Fluffy. You know, but software developers were always great at naming things, right? You know, I'm no different than anybody else. We have the best names for things. And then I can assert that, bring my terminal back here, assert that if I say find pets by kind, that's pet repository, find pets by kind, I want to find a cat, all the pets that are cats, it's not null, it has one element in it, and if I extract the name in the kind, I'm going to get my cat Fluffy. All right, and so now if I save it, yep, my test fail. So now let's go on to the next test. So that's where I get a pet and I find it by name. So now I'm going to do a very similar thing where no pets are found by that kind. So I'm going to again delete all, do the assertion, but now I'm just going to say assert that my pet repository find pets by kind of cat. It's not null, but it is empty, right? Because there's no pets in there. We made sure of that. We asked for a cat and we didn't get any. And then I'm going to do an adopt pet. So again, delete all. I'm going to persist a couple of pets. So I've got my cat Fluffy as a cat, and I'm gonna do Herman. Again, great at naming things, right? Herman is a dog. And now we're going to say assert that my pet repository adopt the pet if found. I'm going to adopt a cat. So it's not null, but it is present. So we're going to call the get assertion that it asserts that it's present. And I can say extracting the name. Again, this should be my cat Fluffy. Right. And then the last, so there's no adoptable pet found, so I'm going to do the same thing. I'm going to persist some pets. So I'm going to say new pet. So I'm going to, I've got Fluffy, my cat. But Fluffy is already adopted by me. And now I've got Herman, the dog, right? And now I can say assert that. So I want to adopt a cat. So it is not null, but it's not present. Right? So now I've got 4 tests that are failing. And you can see why. If I move this up a little bit, you can start to see that my tests are failing. So now let's go implement our logic here. So one kind of cool thing that Panache has for me is this interface has a bunch of stuff that's already there for me. So if I want to return a list of pets, I don't really have to write a query. I can say return a list of where the kind equals the kind. And as soon as I save that, now I've got 2 tests failing, and these are both the adopt. So now I've got to implement this adopt method. So I can say var my pet equals, I'm going to say find kind equals the first argument and adopted by is null, so it's not already adopted, but I want to order it by some random thing which is specific to Postgres, right? But I want to lock that because if I find one, I want to update the record. So I don't want 2 threads to be able to come in and update the same pet at the same time. So I can say with lock, I'll call it a pessimistic write, and I want to return the first result, right? And then I can say, so if the pet was found, if it's present, I can say p.set adopted by, what do I call, owner, and then I can say persist p, and then I can return my pet, right? So if I save this, ordinal parameter not bound. Oh, I said, where kind equals the first parameter, but I never actually gave it a parameter. So I can say kind. Oh, 1 test failed. What's failing here? What did I do? I did something wrong here. PP return pet. Oh, I need a page size. So I only want the first one. So I want page 0, the first page of a size 1, and now it should work. Why is it not working? All right, so now we're running here. I needed to switch the ID of the pet. I needed to let it auto generate one. So now our database layer is done. Woohoo. So now we need to build our REST layer. So let's start by writing some tests. So we're going to say this is going to be our pet. I'll call it the pet API test. The name doesn't really matter. You can call it whatever you want. So this is again a Quarkus test, right? And so we need our repository because we want to mock the layer under our REST layer so that we can control the data it returns. So we definitely need our pet repository here. But instead of injecting the real implementation, we're going to inject a mock implementation. Right? And so now we can add a couple of tests here. So we can say I have a test that says when I issue a get to /pets that I should get some data. So let's set up some mocks here. So when I say when pet repository list all, then I want to return a list of pet my cat Fluffy. All right, back to our great names here. And so now I want to say, okay, when I'm going to use the rest assured library. So when I issue a get to /pets, and I'm going to use rest assured. Then I want to assert that my status code is, let's find the JAX-RS status. Okay. The content type is JSON, and I can say my body. So I have in my request body, my response body, there's 1, and this comes from the Hamcrest matchers. And so then I can say my body, the first element's name is Fluffy. The first element's kind is cat. And then I can also say I want to do a verify that my pet repository, the list all method, was called, and that there were no more interactions on the pet repository. So obviously that fails, right? So there's a bunch of other tests. So rather than watch me type away, I'm going to cheat a little bit here in the sake of time here. I'm going to add in, and we'll walk through this, what I did. Going to add some imports. Obviously, it seems to need a human to make some decisions for it. So we're going to also say when I issue a get to /pets, but I have a query string parameter where I pass in the kind, then I expect, again, it looks like an array of things. In this case is 1 that is adopted by. And then when there's also looks like there's a get to /pets / whatever the ID is, which returns just an object, my pet object. And then there's a get to /pets / ID, and it's going to return a 404 if that pet isn't found. Now, the theoretical debate between whether you return a 404 or 200 in an empty body or some message, we can certainly get together after the fact and have that theoretical debate, but this is the way I've implemented. I kind of fall on the purist side of things, that if you ask for something and it's not there, then you should return a 404, right? Right. Just nod your head and say yes and agree with me. So now, obviously my tests are failing. When I save, I got 4 tests that fail. Let's go ahead and implement this. So we'll call it a pet resource. Again, the name of the class doesn't really matter, not response. We'll call it the pet resource, and I'll put it over here side by side. So this is going to serve requests at the path pets, right? So we can talk about REST semantics and best practices, but if you're serving a collection resource, it should be a noun and it should be plural, and then when you narrow it, it gets to become a singleton in a singular. But all your URI paths should be nouns, not verbs. The other thing I'm going to do is that all my things are going to produce a application JSON. So we said we need our pet repository. And I'm going to use constructor injection. You know, I could have very similarly, instead, if I didn't want to have a constructor, I could say at inject here. I feel constructor injection is the better way to do things. It's more explicit about what the dependencies of your classes are. Either way, it works. It's just kind of the way you want to do it. You know, I typically feel that constructor injection is a better way to do things. So then we have a get all method. So public, we're going to return a list of our pet objects, right? Get all pets. The name of the method doesn't really matter, but if you remember here, so we've got to get to /pets, and then with no query string, and we've got to get to /pets that takes a query parameter. So let's go in here and we'll say optional of string. So this is the kind, and we'll call this a query param, and its name is kind. So now let's say, so if the kind is present, so I'm going to say return kind. If it's there, we're going to map it, and we're going to say this pet repository find pets by kind, or else we're going to just get all, right? Oop. And now we need some annotations here. So this is a get. And now when I save it, looks like it passes. So I've got two tests that are still failing, and those are the get ID ones. So that was pretty easy to implement. So now we've got /pets/ID with a get, and if it's not, it returns a 200 and the pet itself. Otherwise, it's going to return a 404. So there's a few different ways to structure this in JAX-RS. The simplest one that I typically use is I return a JAX-RS response object. And in this case, it's going to take a long ID, and this is again a path param. And this again is a get, and its path is subpath of the path of the class, so it's /ID. And so what I'll do here is I'll say return this pet repository excuse me, find by ID optional. So this method is already there on the Panache repository for me. So I can say find by ID optional. So if it's there, I want to map it. So it gives me the pet. I can say response okay, build. Otherwise, I'm going to return a response of status not found dot build. Save that, and all my tests pass. And so as you can see, all my tests pass. So let's take this one step further. So right now, all these are, we would consider unit tests. Let's build an integration test. And so I can come in here and say pet application IT. All right, and I'm going to cheat a little bit just for the sake of time. I'm going to paste in some stuff that I've already done previously. Let's do some imports. Why I can't figure this out on its own, I'm not sure. Should be it. So we have this Quarkus integration test where the first get all is going to do a get to /pets. It's going to get the response body. It's going to assert that it has 3 records, and it contains these 3, Fluffy the cat, Herman the dog, and again Cutie Pie the monkey. Back to my great naming schemes. Has the gets by kind, get by ID where an ID is found, get by ID where it's not found. And so if I jump out of my my live coding mode here, and I just run Maven verify, Maven is gonna use the failsafe plugin to, after it runs the unit tests, which should run pretty quick, it's going to run the set of integration tests. and it failed, and we'll look at why in a second. But if you look at what it actually did, is it actually ran my application. So it built the application and it executed my application as a separate process, and it basically did a java-jar of my application. Now it's failing because there's no, first off, there's no data in my database. So let's add some default data into my database. So we can say a new file, import.sql, import.sql, and we'll add a few things in there. And then the other thing we need to do is we need to add some things to our application properties. Because where Hibernate automatically creates our schema for us and loads our data in for us, it only does that when we're running in our dev mode. So we need to tell it that when we're running outside of dev mode, we want to do that as well. So if I rerun this, and instead of just saying even clean verify, I'm going to say container image build true. And what this is going to do, again, it'll build the application, it'll run the unit tests. Yep, it's running our unit test. It started a Postgres container. Now it's building. Looks like it's actually using Jib. Remember we added the Jib extension earlier. It built a container image, and now it's actually, you see it's doing a Docker run of that image that it built, and it's going to run the tests against that container image, which is pretty cool. Yep, it just takes a second. Yep, see, now it ran. Started down, everything is good. It ran my container image. All right, and so now our code works and we can prove it. Hooray, hooray, hooray. The sun is shining and all is well. And so there's some additional resources here. We got to wrap it up, unfortunately. I can't really go into a lot of this stuff, but if you get the slide deck, there's a bunch of resources in here. There was a couple article series about Quarkus on InfoQ. There's a lot of great books out there that you can download. There's the Quarkus Superheroes, which is the official sample application teaching you how to use Quarkus, how to build Quarkus applications. It's a whole lot more than Hello World. Antonio Goncalves and I have done a couple different talks on using the superheroes on top of Azure Container Apps. We've also got the Quarkus World Tour, which we can arrange for private stops if that's something you're interested in, or get in contact with your local Jug. And some resources around if you're interested more on Quarkus, Quarkus.io, and the Twitter handle. And thank you very much for attending this talk at J4K. It was great to be here. Thank you very much.